Hello everyone. In this video I would like to demo another application of the Play 700 system on Windows and comparing between solving a solution I call taunting the dog. Of course this is not recommended on a real one but this is a robot, you can okay. The main thing is it's an interactive game using the dog robot. And I'm going to show you two coding approaches, one using the tasks and one using the Crash 2. And you can see that they have different performances, interesting regarding real-time control aspect. So let's get to it. So quick look. Oh, very important, because we're dealing with we're trying to make things as fast as possible, so best reaction from the robot possible. So we all need to go to device manager and the two COM4 and 5, which happen to be the COM port open on my BT210. So make sure everybody goes as high as you can. So a bit per second, 128,000. Okay, and then this is the task version. Essentially just an endless loop. And then you go in and read the IR center, and then if the IR center bigger than 50, basically you make the dog run toward you. So basically you're taunting it, it runs toward you, but as soon as you remove your hand, else it stops. So basically it kind of trying to snap after you pretty much. So that's the task version. The actual task code is here. Oh, very important. Remember we had a previous video where we play with it. Make sure to disconnect from here, from the upper scratch, so that the task can connect to it. Also, I'm going to turn off the robot just to reset all communication lines, just to be sure. Turn it back on again. I'll leave it there. Okay, so let's download. Very good. Disconnected. It's downloaded. Now we are essentially ready to play. It's not printing anything, so I don't need to go anywhere. So remember to turn it back on again, and then it should be running now. So you see every time I push close, jump after me. So pretty snappy guy. Okay, that's kind of the intent for the code. So let's minimize that. How about we do it on Scratch? Now this is very important. It is I just realized by trial and error. So remember I had this task program still running. Okay, as soon as I connect it through plus Scratch here, so that I can do Scratch 2. So you see it's connected. What I found out is whatever task program I have there is no longer running. As soon as Atlas Scratch connect to the robot, and you can see it's connected here, immediately any task program is closed, terminated. So that's because it's interesting. Okay, so what does the actual code to do this look like? Actually, it turned out in this particular case, see the task program is here, have an if else, essentially an endless loop. In our plus Scratch is pretty much the same, have forever loop. Inside you read the IR center, save to temporary variable called sensor, and then you check the current value of that one. If it's bigger than that, you turn port 1 on, port and port 2 on to jump forward. If not, you turn everything off. So you see the code is exactly the same. Let me leave it here, just out of your way, so I can put it back in. Oh, let me be able to put it here then, so that you can see. Okay, so let's see how does it work. So our Scratch is connected, and it's working now. You can immediately say that The dog is a little bit more sluggish. It's still doing it. It's sluggish, but I don't know if you saw it. It kind of jumped to the left of it a little bit every time it started. Okay, let's see if you can catch it with the video camera. Okay, let me try again. See? It click over before it does that. And that is very interesting there. And let me do it real carefully so you can see. Let me pick it up. And let's see. I'm gonna approach the sensor from the top so it won't be in the camera. I don't know if you saw it, but this wheel is running before the other one. Always. A little bit. So that's so this is the wheel on the right. It always turn on before the other one. So make it jerk to the left a little bit every time it starts. And if you look at the code, there it is. Port 1 first, so it turn on first before the one. So it's very noticeable if you run it through Scratch 2 code. But if you remember, it was not noticeable at all when we had it a task. But then you have to remember is through task, the code actually running on the MCU of the robot itself. So it's right there, very close. So this is interesting. These communication going from Scratch 2 to R+ Scratch to the robot back and forth, and there's noticeable delay. Okay.